Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU Actuary. And here's the problem for today for exam P on probability. A company offers a basic life insurance policy to its employees, as well as a supplemental life insurance policy. To purchase the supplemental policy, an employee must first purchase the basic policy. Let X denote the proportion of employees who purchase the basic policy, and let Y the proportion of employees who purchase the supplemental policy. Let X and Y have the joint density function f of xy equal to 2 times x plus y on the region where the density is positive. Given that 10% of the employees buy the basic policy, what is the probability that fewer than 5% buy the supplemental policy? And here's the solution. So we note first that we must have y less than or equal to x as no more than proportion x buy the supplementary policy, because in order to buy the supplementary policy, you must have the basic policy. The region of positive joint density is the triangular region 0 less than or equal to y less than or equal to x less than or equal to 1, which is below the line y equals x inside the unit square. We want to find conditional probability that y is less than 0.05 given that x is equal to 0.1. The conditional density for y given that x is equal to 0.1 is f sub y of y given that x is equal to 0.1, and that's equal to f sub xy of 0.1y divided by f sub x of 0.1, where f sub x is of course the marginal density of x, and here it's evaluated at 0.1. And we find it, that value, f sub x of 0.1, by taking the integral over all possible values of y. And of course, we note that 0 is less than or equal to y less than or equal to x, which is 0.10, so y runs from 0 to 0.10 of f sub x y of 0.1 and y, so specifically for x equal to 0.1 as prescribed, dy, and that's the integral from 0 to 1 of 2 times 0.1 plus y dy, and that's equal to 0.03 by calculating this. And therefore f sub y of y given that x is equal to 0.1 is f sub xy of 0.1y over f sub x of 0.1, and the numerator is 2 times whatever the value of x is plus y, but x is 0.1, so 2 times 0.1 plus y over 0.03, and therefore the probability that y is less than 0.05 given that x is equal to 1 is the integral from 0 to 0.05 of this density, 2 times 0.1 plus y divided by 0.03, and we factor out, actually we don't factor out, sorry, we just split this into, we multiply out the top and split it into two pieces, two quantities. The first one is 2 times 0.1 over 0.03, and we take the integral of that, and that's the same as 0.2 over 0.03 or 20 over 3, multiplied by the length of the interval, which is 0.05, plus the second part is 2y over 0.03 dy, and then we evaluate it from whatever integral we evaluate it from 0 to 0.05. So what is the integral of 2y? It's y squared. And 0.03 is 3 over 100, so reciprocal of it is 100 over 3. So this becomes 100 over 3 times y squared, evaluated from 0 to 0.05. And now we calculate this whole quantity as approximately 0.4167, which is answer D. Please remember that this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.